Japan's SLIM probe made history with its remarkable landing on the moon. Japan became the fifth country to land a spacecraft on the moon. This massive project was completed after years of work and was equipped with advanced technology that could revolutionize space exploration as we know it. However, amidst the excitement, something dark and mysterious was discovered on the probe. It appears there was much more behind this mission than the world knew. What happened to the SLIM probe on the moon? What are the secrets of this mission, its true purpose, and its impact on space exploration? In this video, we will uncover everything about Japan's Lunar Smart Lander mission. We finally found what NASA has been hiding. On January 19th, the Japan Aerospace Exploration Agency, JAXA, landed its special probe, SLIM, on the moon. This incredible achievement made Japan the fifth country to land a vehicle on the moon. The project dates back to 2005, starting with the idea of creating a small lunar lander experiment. By 2013, SLIM was proposed as one of the ISS Focus missions. In April 2016, SLIM became an official JAXA project, and Mitsubishi was awarded the contract to build the spacecraft. The main goal of the mission was to test a new landing technology. If successful, the project would demonstrate the possibility of landing precisely on a specified point on the moon or another planet. SLIM's journey to the moon took about 4 months, beginning with the launch alongside the X-ray imaging and spectroscopy mission, EXM. After separating from EXM, SLIM changed its course and prepared to enter lunar orbit. On December 25, 2023, it successfully entered lunar orbit and performed one of the most precise lunar landings ever seen. Lunar landings have always struggled to achieve pinpoint accuracy. The Smart Lander for Investigating the Moon, SLIM, aimed to overcome this challenge using modern technology. The success or failure of the mission would demonstrate the new method of making perfect landings on the moon or other planets to the space exploration community. NASA and other space agencies have long focused on landing at specific points on the moon instead of anywhere on its surface. The mission succeeded when SLIM made a highly precise landing at the designated spot on January 19th. However, despite the probe's soft landing, there was an issue with its power supply. The probe's solar panels were facing away from the sun instead of towards it, making it impossible to charge SLIM. JAXA's ground team had to deploy the 2 rovers using backup batteries to conduct measurements on the lunar surface. Additionally, the multiband camera, MBC, mounted on SLIM, was able to capture some images during this time. Based on the data collected from the device, JAXA confirmed that the probe did not suffer significant damage during the landing. Therefore, they decided to leave the probe on the moon until sunlight could reach the solar panels. A lunar day is 14 Earth days long. If you were on the moon, it would take 14 days for the sun to rise and set. Initially, JAXA planned for the probe to operate for at least 2 weeks using solar energy. However, due to the unexpected landing orientation, the only option was to wait for the angle of the sun to shift towards the solar panels. This process demonstrated that Japan's method in this mission showed it is possible to land precisely on a specified point on the moon or another planet. Additionally, they proved that a soft landing is also achievable, which was a challenging task even for agencies like NASA. During NASA's Apollo missions, one thing they could not achieve was landing at a specific point. For example, when Neil Armstrong and Buzz Aldrin were landing the Apollo 11 lunar module, they encountered numerous complications. Initially, they faced severe communication issues with the base, followed by various alarms being triggered. The automatic landing systems failed, and Armstrong had to manually land the module. Even then, they landed entirely off-target. SLIM's precise landing at the designated point is a significant achievement. Recently, attempts to land on the moon have generally ended in failure. Usually, probes crash when trying to land on the moon. Moreover, they crash into unintended places. Japan's Slim, on the other hand, made a soft landing at the intended spot and was able to deploy its rovers. For example, if a rocket suddenly loses one of its engines during flight, the worst-case scenario is that it crashes and burns. The best-case scenario is an emergency landing. Slim landed at the designated point, earning Japan a highly respectable position. In the 21st century, China has been the only country to successfully land on the Moon. 50 years ago, while NASA was landing astronauts on the Moon, why do today's lunar probes that struggle with landings? Experts cite various reasons. Back then, there was a space race. The United States and Russia were competing for dominance, and space was the battlefield. NASA received full support from the US government to develop the best lunar modules, rovers, and landing vehicles. Today, nations conduct lunar missions mainly out of curiosity or to make a name in history. Hence, today's probes are built with lower quality materials to minimize costs. Additionally, most probes are made by private companies, and private companies have a 100% failure rate on the Moon. Communication is a significant issue on the Moon. The massive white satellite constantly interferes with radio signals, causing probes to land inaccurately. Since there is no atmosphere on the Moon, landing with parachutes is impossible. Landing relies entirely on engines. The pilot or control must find a way to slow the descent. Otherwise, if the probe is too heavy, a crash is inevitable. China's Chang'e 3 mission in 2013 was the first soft lunar landing since Russia's Lunar 24 in 1976. Most other countries have met a worse fate. Japan's Slim solved all landing issues. JAXA continues to be recognized on the international stage as a reliable partner of NASA. For the next mission to carry humans to the Moon, the Artemis program, it is certain that this new Japanese guidance system will be used. However, there is a major problem. Slim encountered an unexpected issue during its landing on the Moon. JAXA reported that one of the probe's engines stopped working during the descent, and they are still uncertain about the cause. Until this mystery is solved, there is no guarantee that future NASA missions will proceed as planned. So why did Slim land face down? JAXA had carefully designed the probe to land upright. For example, the legs were equipped with crushable zones to ensure a soft landing even at high speeds. The targeted landing site was a 15-degree slope area of an impact crater known as Shoemaker Crater. The probe landed just 55 meters away from the targeted point. This point was chosen to receive the maximum amount of sunlight. The probe's rear legs were slightly shorter than the front legs to compensate for the slope. The vehicle was programmed to tilt at a 45-degree angle before touching down to ensure a softer landing. However, Slim landed face down, and no one knows why. A scary theory suggests that aliens might be responsible. Experts propose that there may be unknown entities on the lunar surface. Some people believe that aliens live on the Moon, and that these entities do not want any human presence on the Moon. Was the Japanese probe redirected by a foreign entity? Some conspiracy theorists claim that Slim encountered UFOs on the Moon. Did these UFOs change the probe's trajectory? These theories might sound wild, but they are currently scientifically unverified. Whatever the real reason, Slim's failed landing has raised many questions about space exploration and lunar missions. Japan's success on the Moon opened a new chapter in the history of space exploration and laid a foundation for future missions. The information gathered during this process could be crucial for the future of space exploration. The research and results JAXA will achieve in solving this mysterious situation could open new doors for humanity in space.